Humans, hello. We're going to go over the quiz review really quickly. Pause it if you need to, go back if you need to, check it if you need to, but here we go. We've got number 1, A, approximate each of these square roots. Well, you've got square root of 16 is 4, you've got square root of 25 is 5, and you've got a number of 9 in between these two, and looks like square root of 22 is about 3 away, so a third of the way. So how about 4.6? It's a third of the way away from here, 2/3 of the way this way. I'm going to guess 4.6-ish. Okay, for B, you've got square root 30, negative. Again, let's see what we know. What we know is the square root of 36 is 6, and we know the square root of 25 is 5. About halfway in between, but closer to 25, is the square root of 30. Okay, so how about 5.4-ish? But remember, it's negative. So we're looking at about 5.4 negative. And the last one, C, is square root of 126. I know square root 121 is 11, and I know square root 144 is 12. Much closer to 121. How many numbers are in between? About 23, and we've taken care of 5 of those, so it's no more than a fourth of the way. How about 11.25? How about 11.2 even? It's less than a fourth of the way to 1.4. All right. Let's keep it. Keeping going. Number 2a, we've got a squared minus 13 equals 68. We want to isolate the variable, just like we're solving any equation. We've got 13 on both sides. That gives us 81 is a squared. We're interested in just a. A is being squared, so let's square root. The inverse operation of squaring is square rooting. The square root of a squared is a. The square root of 81 is 9. Okie dokie. For B, 3m squared equals 588. To get m by itself, we divide 3 on each side. Now, since I don't know the square root of 3, wouldn't it be great if these numbers could divide? 588 and 3. They can. I think it's 196 today. M squared. You were looking for just m, so let's square root it. Let's square root over here, and we've got m equal to 14. Cool. Keeping going. 3/4 x squared equals 16 thirds. All right, well, you have something that's next to the x, that something is multiplying the x. We can do the inverse operation of dividing 3/4, but we know dividing a fraction is the same as multiplying its reciprocal. So let's multiply its reciprocal on both sides. This way we'll have just the x squared left on the left, and on the right side we'll have 64/9. By golly, that's looking good. When we square root each one of these sides, it's the same as square rooting the top and square rooting the bottom. The square root of the top is 8, the square root of the bottom is 3. Cool. And lastly, we've got D. 6p squared plus 3/5 equals 7/10. Now, to approach this, I would clear the equation of all of its fractions by multiplying everything by 10. When we do that, we'll have 60p squared plus 30 over 5 equals 70 over 10. And that's the same as saying 30 divided by 5 is really 6. And 70 divided by 10 is really 7. When you subtract 6 from each side, you can see that 1 is equal to 60p squared. And when you divide 60, you'll see p squared is equal to 1 over 60. Well, to get p by itself, let's square root both sides. And we can see p is equal to the square root of 1 on top is just 1, and the square root of 60 is the same as saying the square root of 4 times the square root of 15. Let's write this so we can read it. Okay. And we've got, so p is equal to 1 over, the square root of 4 is 2, and the square root of 15, I don't know. So this is actually your final answer. Looking at this problem again, we had the square root of 1 over 60. That's the same as the square root of 1 over the square root of 60. The square root of 1 is just the 1 on top in the numerator, and the square root of 60 can be broken down into 4 times 15. The reason I like this is because 4 is a perfect square. The square root of 4 is this 2 here, and you're left with the 15 underneath. Yay! Okay, here we go. This is number 3, and 3a happens to be simplifying the square root of 60, which we just did, so I won't spend much time on that. You've got the square root of 4, which is 2, and the square root of 15. It's as simple as you can go, because you can't take the square root of any part of 15. Here we go. For b, you've got 20 over 144, and you're taking the square root of that. I'll split it into the square root of 20 over the square root of 144. On top, you can see 4 times 5. You're taking the square root of that. Square root of 144 is 12. On top, you've got the square root of 4 is 2 times the square root of 5 over 12. And you can simplify the 2 with the 12. They have a common factor of 2. Divide the top by 2, left with 1 square root of 5. On the bottom, divide by 2, and you're left with 6. There's your final answer there. For C, moving right along, 180 times x to the fourth times y to the second. 180 can be broken down into, let's see, I think 4 divides 180, but what does that leave you with? It leaves you with 45. There's 4 45s in 180, but if you look at 45, before we go any further, 45 is nothing if it's not 9 times 5. So how about 9 times 4 times 5, that is 180, and you still got x squared, which is x to the fourth, and you've got y squared. Okay, here you have 36 underneath a radical, and you have the square root of 5, the square root of x squared, the square root of x squared, the square root of y squared. You know the square root of 36 to be 6. You know the square root of x squared to be x. And you know the square root of x squared to be x. So x times x is x squared on the outside. And you know the square root of y squared to be y, with a y. And you got rid of this, and you're only left with this. Well, we don't know the square root of 5, so we can just leave it like that. Here we have it. Sick. Let's keep going. D. Square root 121 over 9b squared. Split it up. Square root of the top, square root of the bottom. Square root of the top is 11. Square root of the bottom is 3 with a b. Anytime you have a number being squared, the resulting square root is the squared thingamajiggy. Okay, that's that. Moving right along, let's make this a little bit smaller so we can keep it all on the same page. Whee! Alrighty then, we've got E. 64, the square root of that. over the square root of 24. The square root of 64 is 8, and 24 is nothing if it's not. 4 times 6 works. 6 is 2 times 3. That doesn't help us though. So how about 8 over 2 times the square root of 6? But you can simplify a little bit further here for 4 over square root 6. Sick. And F. 80 square root minus 20 square root. Now, 80 definitely has a 10, but 10 and 8 doesn't help as much. Definitely has a 5 involved. 5 times, oh my goodness, 16. I'm going to look at that square root. Minus 4 times 5 is 20. And this looks good because I know the square root of 16. The square root of 16 is 4, and you're left with square root 5. Minus the square root of 4 is 2, and you're left with the root of 5. Well, if you have 4 of something and you minus 2 of something, you have 2 of the something. Just like saying 4x minus 2x is 2x. In the same way, this answer would be 2 times the square root of 5. Awesome. Last one for this little section. We'll do it up here. It's a lot of math going on here. G is square root 8 times square root of 12. Square root of 8, I don't know that, but I do know 4 times 2 is 8. And I do know 4 times 3 is 12. I can take the square root of 4, which is 2, leaving a 2 underneath. And I can take the square root of 4, which is 2, leaving a 3 underneath. When I multiply the numbers with the numbers, I find 4. And underneath the radical, I have 2 times 3 for 6. That looks good. Moving on. Okay, Oakley, a squared plus b squared equals c squared. That's the Pythagorean theorem. If you have a right triangle where you have a and b as legs, you can find c to be the sum of the squares of the legs. Here we go. For 4a, you've got 6 and 8 and c. Well, the legs are obviously 6 and 8, the things that make up the right angle. And the c would be the thing across from the right angle, the hypotenuse. You have 36 and 64 is equal to c squared. Looks like 100 is equal to c squared. Now you can see that c is being squared. In order to undo that, you need the inverse operation of squaring something, which is square rooting something. Square root both sides to see that 10 is equal to c. Looking at b. B says you've got 12 as one of the legs, you've got b as one of the legs, and you've got 13 as the hypotenuse. Be careful. This correlates to the hypotenuse, c. So you've got 12 squared plus something squared, the legs, equal the hypotenuse being squared. 12 squares, 144 today, plus b squared equals 13 times 13 is 169. Subtracting 144 from both sides to try to isolate the variable. And you've got 25. Yes, that's a good number to have because we've got a square root. B squared, in order to undo that and look at just b, you need to square root something that's being squared. If you do it to one side, you best do it to the other side. The square root of 25 is 5. Delicious. Let's keep going. Wee srinkaroo. Let's look at C for number 4. And we're looking at, here's a triangle. There was supposed to be this little mark in it to tell you that's a right triangle. You've got the legs measuring 7 and the square root of 51. So just over 7 it looks like. And the hypotenuse is unlabeled. You have the Pythagorean theorem, which says the square of one leg plus the square of another leg should be equal to the square of the hypotenuse. Squaring something that's in a square root results in the thing that's underneath. There we have it. And 49 is x squared. Guess what? That's convenient. 100 equals x squared. to find out x alone, you square root both sides and see that x is worth 10 again. Yes, this is fun. Last but least to greatest, is how you're asked to order these numbers. Let's take a closer look at what these numbers are underneath the hood. Here we go. We've got this, 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 and we almost don't even have room for this. Okay, so the first number, the square root of 81, 9. The square root of 225, 15. Well, you can simplify that, dividing 3 on each of those, so 3/5. And next, you have the square root of, oh my goodness, this is moving, this is moving, this is moving, somebody stop. Okay, so you've got the square root of 18, which is nothing if it's not 9 times 2 underneath. Square root of 9 is 3 times root 2. So that's what you really got there in second position. In third position, let's just leave this like this so far. In fourth position, it's easier to look at 4/3 as 1 and 1/3. 1 and here's 1/3, repeating forever, and that's negative. And in this position here, you've got 13 divided by 4 is 3, with 1/4 left over. And finally, square root of 22, whatever that is. All right. Now, let's inspect some of the ones that look kind of tricky, which are only these ones. The rest of them are pretty straightforward. In fact, we can change 3/5. 3 divided by 5 is 0.6. So that's that first idea. All right. Well, what is the square root of 2? The square root of 1 I know is 1. The square root of 2 I don't know. The square root of 3 I don't know. The square root of 4 I know to be 2. Notice how there's a gap here. 1 gap, 2 gap, 3 gap. So let's assume these are equal spaces here, or roughly equal spaces. If we did assume that they are equal spaces, there's about 1/3 of a distance from here to here. So if you wanted to approximate this root, perhaps it would be 1.35, or in between 1.35 and like 1.45 probably is a safe guess. If you did assume that, and you multiply that guesstimate by 3, because that's the number out in front of this square root, the number will be bigger than 4, or right around 4. Looking at these numbers here, no number is bigger than 4. Maybe this one is, though. So let's inspect that one. I know the square root of 25 is 5. I know the square root of 16 is 4. And if you think about the number of spaces in between there, there's 9 equal spaces. The 22 is 3 away. So, this one's going to be tough. 3 out of the 9 away, so that's 1/3 of the way back this way. 1/3 of the way back that way leaves you at 4.6. We were assuming that this one, at its most, might be like 1.5. Still, if you multiply 1.5 by 3, it leaves you with 4.5. So, looking at this one as it relates to this one, it looks like this one here is the biggest. And if it's bigger than this one, it's the biggest out of them all. Let's shrink this down a bit, and let's crown the grand champion as the square root of 22, because that's approximately equal to 4.67. And closely behind it is 3 times square root of 2. And so we've got rid of this one, we've got rid of this one. Looks like 3.25 comes in third place, going from biggest to smallest now. And then 0.6, of course. And you see, square root of 3. What is the square root of 3? I don't know. We have this argument right here. Working backwards with this argument, square root of 3 might be close to 1.67. So still bigger than this one here, or bigger and negative means it's less. So that's the grand champion of the least of these. And now you have negative 1.33, which is the negative 4/3. And this one's the square root of 3 negative. This one was 81 over 225. And this one was 13 over 4. And these ones
where this one was the 18 square root, and this one was the 22 square root. Of course, we should have just looked at these originally. Oh, look at us. Here we go.